Jeez. All right, we're live. Here we go. Hey, what's up everybody? Welcome back to another 3D Hangout. I'm Noe, designer here at Adafruit. Joining me every week, Mr. Pedro. What's going on, everyone? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit. This is a show where we combine 3D printing and DIY electronics to make inspirational projects for you folks. Let's start off with the show. On today's show, the coupon code is CIRCUITPY. So if you get anything in the Adafruit shop, make sure you put this in your checkout. The coupon code is CircuitPython. You'll get 10% off everything except subscriptions and
gift certificates.
Thanks so much. We also got some great deals for you. If you go to adafruit.com/free, you can find all the great deals. For the folks in the US, Continental, you can, if you order anything over $200, you get free ground UPS shipping. For the fine folks in New York City, we also have same-day delivery. We have an Adafruit daily newsletter, so be sure to check that out. If you want daily content from Adafruit in your inbox, you got to opt into that. That's adafruitdaily.com. If you want just something weekly and more product driven, we have a newsletter for you folks. It's called the new newsletter. Go to adafruit.com/newsletter to kind of subscribe to that one. Cool. So let's get into this week's project. I hope you guys checked out this week's project. If you haven't already, this is it. This is a CircuitPython powered USB keyboard emulator. So this was a project that was really a necessity type thing that we needed. So Mr. Lady Ada, Philip Tyrone, he really wanted a way to be able to switch between scenes in Wirecast. Wirecast is the broadcasting software that we're using right now. So what's kind of meta about this is, watch me as I hit this button here. I just switched to our face cam. Now I'm switching to the coupon code. And now we're back to the overhead. This is awesome. This is just 4 arcade buttons and an Adafruit Feather M0 Express, which is in here. There's no battery in here. It's USB powered. And probably the most awesome thing about this is I can quickly modify the code for this project. So if I go over to this screen here and hide that, I can actually show you guys the code that's running on here. So this is when you plug in an M0 Feather into your USB drive, you get a mass storage device. In the mass storage device, you have the option to reflash the firmware, and in this case, I've reflashed it to be CircuitPython. So by default, it is Arduino land. So you just have to do one quick thing to get it to CircuitPython. So it's really awesome. I can modify this code here. I can bring this into, I can plug this into any computer, just about any computer, and modify the code. So this is all the code that's running to make this happen. So you can see here, I am defining the button pins, the LED pins. That's where they're wired to. You can have up to 6 buttons when you're doing it this method, where you're just using digital pins and analog pins. And then you can change the key control, or the key codes here. And you also have an option to put a control key. So if you want to do like macros and stuff, like key commands, you can do that here. So check this out. The software will be up on GitHub very shortly, hopefully by the end of the day, if not within the week. And let's take a look now at the learning guide for this project, if I can get there. Hopefully I can get there. There we go. Cool. Okay. So let me back up a little bit here and just show you the overview page. Overview page just talks about the project, has some prerequisite guides. If you are new to electronics, definitely start off with the soldering video from Colin and the Feather M0 Express guide, just to get more idea of the software, the pinouts, all that sort of stuff for the Feather M0 Express. These arcade buttons, again, really nice quality arcade buttons, 24 millimeter in diameter, and they have the built-in LED with resistors. So they have 2 sets of electrode prong thingies. But really all you need is just a couple buttons and the Adafruit Feather M0 Express to do this project. So it's pretty cool. Very, very short, very small amount of components. A couple hands of tools. I always throw in there all the tools that I use for all the projects. A couple ideas and things out there. You can make this into a game controller because it is a USB keyboard. So it worked well as a game controller. For us, we're using it as a media editor controller. So I could definitely use this not just for Wirecast, but I could use it for Premiere or Final Cut or even After Effects, or whatever software thing you use. I think it's also good. It could also work well as an assistive technology button. So it's really easy. It's a large surface area. I think it would work well for accessibility projects. So just a couple ideas out there for you. The circuit diagram just outlines where all the wires go and where. I've broken out purposely the LEDs from the buttons because it's just a little bit easier. And if your buttons don't have LEDs, here's how you would do it. But yeah, all the grounds are connected in series, so they all go to just one ground connection. Pretty cool. Again, I just want to note that this method that we're doing here, it's not using multiplexing or anything, so we're just going one button goes to one digital pin, and the LED goes to one analog pin. So you have up to 6 available pins. If you want to do more than that, I definitely recommend checking out this project from Scott, Chickadee63. He actually made a 63 key keyboard with CircuitPython. So if you want that project, you want more buttons, if you're really serious about it and you're a developer yourself, definitely check out Scott's project. And a huge shout out to Dan Halbert, who actually put together he's actually working with us now. He put together the USB HID CircuitPython library. So if you want to see what key commands are available, check out this page here. I'll have a link below, and it's also in the guide. So of course, all the characters A through Z, numbers, special characters, tabs, function buttons, commas, periods, I think even media buttons like play and pause and things like that, keypads, number pads, F1s, they're all here. So if you want to get a list of what are some available key codes, they're all right there for you. I need to take a break to breathe. The software portion of the guide walks you through how to get CircuitPython enabled and set up on your Feather M0. Very, very simple. By default, it is in Arduino land. To get it to be a CircuitPython mode, just double tap on the reset button and it'll change the NeoPixel, the onboard NeoPixel will turn green, letting you know that it is ready to be flashed or just ready. It's in that CircuitPython mode. But in order to get the latest build of CircuitPython, all you got to do is download the UF2 file. Once you download that file, you just drop it onto the mass storage device that's called Feather Boot. So when you first plug in your Feather, and you haven't hit once you plug in the Feather, double click on the reset button, it'll name the drive as Feather Boot. When you drop in the UF2, it'll automatically reset itself and change its name to CircuitPy, which happens to be the coupon code. So once it's that simple. Okay, once it's set up for CircuitPy, you just drop in your Python code and any accompanying libraries. But most of them are already built in to the SPI chip. So cool. I also list out here, of course, Lamar's stream. So if you want to get more detail about the software or watch her actually develop the software live, you can do her in this video. Prototyping it is pretty easy. I'm just using one jumper wire to kind of tie ground to one of the GPIOs. And it's a really quick way to kind of prototype. Testing LEDs is also important, so test your LEDs. All right, about the printing part of it, I made a couple of different versions of it. I'm using the 2x2 because that's really all I need. I don't need anything more than 4 buttons, but I made one that, of course, that has 6 buttons, and I went out and made one that has a bunch of buttons. So you can check this out. This was a parametric design. I put together 2 different layer by layer tutorials on it, so if you're really interested in CAD land and you want to do some parametric designs or see how this is working or how I developed it, you can check that out. The assembly it's one of those projects where you have to kind of assemble it before you wire it. Anything that's panel mounted, you kind of have to mount them first and then you wire them. So you got to do that. A lot of wires here. There was a tip actually in one of the YouTube comments. There's a wire stripper that can actually strip in between a long stranded wire. That would have made it a lot easier. Definitely going to do that. I don't do projects that have a ton of wiring usually. This is one of those projects. I also break out kind of where the LED electrodes are and where the button electrodes are for the arcade button. So hopefully that's helpful for people. Wiring it is pretty straightforward. We're just wiring everything in series. All the ground connections get wired in series first. So the more buttons, the more wires. Okay. One thing I found interesting though is that to kind of make this easier is I found it if you solder 2 wires to one electrode, you'll definitely save a little bit of time there instead of having to wire and then, oh, it comes off again. Anyway, read the guide on that portion of it. Yeah, that's the kind of project in a nutshell. So I'm actually using it. Okay, I'm actually using it right now. So kind of meta to switch between it.
Actually, no, I think the most meta thing is plugging CircuitPython in and changing the code by clicking some characters that are on the buttons.
Yeah, that'd be kind of fun, huh? This is it's not going to do anything here, but yeah, Lamar even wrote the code so that the LED lights up every time I press it.
Very nice.
So it's pretty neat. As far as like latency and stuff, I think it's pretty quick. I don't know exactly what the milliseconds are on the delay, but I think it's pretty good. Especially for something like this where I just need to execute a quick command.
Yeah,
Hope I'm not disorienting anyone.
I tested this to see if it's the latency is fast enough for something like music, right?
Yeah, so say like virtual MIDI mapping, yeah, it might work. Or
So
it
one
might
of the
be good.
coolest things about this, if you guys haven't checked out the layer by layer, is the user parameters that you set in there to actually turn this into...
Yeah, it's too big to show on this over screen. Yeah, so this is a 4x4 button. Obviously, there's more buttons than GPIOs, but you would have to do that multiplexing stuff. It's totally possible.
A lot of the comments of people who were saying, oh, this is like a poor man's MIDI fighter. Absolutely.
Yeah, this was just like a kind of a test really for the Type A machines to print the biggest thing I possibly could. So this is an 8x8. That's 64 buttons in total. That would be a nightmare wiring. So that's why I'm not going to do that. Plus, I don't have the chops to write my own multiplexing code.
Actually, if you guys are interested in that, I think Scott does have some code.
Oh yeah, we can show it again. I know you were doing stuff, but yeah, I totally showed Scott's thing. So if you actually do want to make, well, it's 63, but I'm sure you can add 64. Right? What's one other button going to do? So check out Scott's GitHub page if you want to do a Chickadee 63.
So Dana is asking,
Yes?
what is the limit before you have to add a second featherboard? You wouldn't add a second featherboard. You would just multiplex it.
Yeah. You would multiplex it.
But the limit to how many you could do with just one feather is 6, right?
Yeah, if you're doing it this method where we're going from one button to one GPIO. Yeah. I think, yeah, this is pretty interesting. What will happen, I think what we'll do is we'll try to come up with we'll try to collaborate with Scott to make this into a project.
So Scott already did the keyboard. We can actually just like 3D print the backing for it.
Okay.
Since we can send out the
PCBs
PCBs that he made.
PCB, yeah.
So that'd be cool.
Yeah, but this is like, hopefully you could use Scott's code and just wire it into whatever chip, into whatever board. Okay, so that's that part. So if you want to make really big ones, one of the mics is off.
Did you? No, I already turned it back on. It's when I was
thanks.
coughing that I turned it off.
Oh, okay. Yeah, Pedro's a little under the weather. Just a little bit. Okay, so that's the project. I hope you guys find it useful. Again, I really see this being helpful for assistive technology projects. I think, especially since it's running CircuitPython, you can plug this into any computer, and you can get you don't have to install Arduino IDE to update the code. Anybody can just open the text file and modify the code right then and there. I just showed you guys on my desktop the code. I can go in there and literally change it, like Pedro was saying is meta. I could actually use the project to make the code. It's kind of weird, but hey, it works.
And that's one of the things we need to keep reiterating in terms of why we're moving a lot of things over to CircuitPython. You don't need an extra IDE like the Arduino to actually compile the software to write it onto the chip.
Yeah.
You just plug it in like a regular USB drive. It shows up like, a regular drive. You open up any text editor and you can just type in the code to change out in there. So a lot of the projects that are like, when we first started Adafruit, a lot of the libraries have changed, so we can actually go back in there and redo some of the animations that we've done before without actually having to change
that's one
a lot
of the things that's kind of limiting. Like once you have your code on your Trinket or whatever Arduino clone microcontroller, you're never going to see it again. You can't get it out of it. You know, it's been compiled into assembly.
We're getting requests for Scott's code. Link to it in the show description.
Sure.
So if you guys go over to GitHub, we'll do it too. We'll link it as well, but it's under github.com/.
I guess I could do it now. People want it, man.
It's really good stuff.
Check it. 10 to newt. Scott S. holding it down with the chickadee. Really cool. So check that out if you are interested in doing a full-blown keyboard, because Scott's done it and he was really inspired to do it.
Yeah.
So
he actually custom made it because he wanted a small keyboard that he can travel with when he was overseas.
Right.
So it worked out really well.
Worked out well, yeah. He did it. He wrote the code. It's awesome.
All right. So if you guys want, as you've mentioned already, if you want to check out the full guide on how to create zero parameter models to change these out, even in the guide it shows you what parameters you have to change the button layout on this. You can check that out.
Yeah, that was my part. I'm happy about it.
Works out really good.
Yeah, it was fun. It was a great exercise in user parameters as well. So, the most parametric box I've ever made. Box full of buttons. I love me boxes. Very, very cool. So if you guys have any questions about it or anything like that, let us know in the comments and we'll answer you as we do the show. So that's this week's project. I hope you guys liked it. It's very useful. We're going to be using it in the show every single show now.
Makes it a lot more enjoyable to actually switch between scenes without having to get messed up in clicking around inside of Wirecast. So
yeah.
Very cool. I like it. And I think one thing we didn't mention too, the rubber feet that we're adding onto this are one of the...
Get yourself some rubber feet. If you have a lot of projects that you need to hand and they're slipping all over the place, NinjaFlex isn't really going to cut it. This stuff is like silicone rubber based.
So typically we would say to try this out in NinjaFlex, but this is some sort of silicone or something that's a little bit more stickier than even the original NinjaFlex, which is pretty rubbery.
And they're big, nice and chunky, like gumdrop rubber feet. So just, I don't know, type in rubber feet in the Adafruit store. I don't know how much they are. I think it's a set.
I get a set.
I'm going to leave that page. Don't forget about that. That was a fun one. All right, so again, if you want to pick up the buttons, you want to pick up any CircuitPython boards, the Feather M0 is a nice one to start with, or the Circuit Playground. So we have 3 different choices for you. We have the M0 Feather, we have the M0 CircuitPython Express, and we have a Metro. If you want a full-blown Arduino, that's the Metro.
Somebody was asking, could they actually use the M0 Bluetooth to turn this into a wireless?
I don't know.
We'd have to rate some different stuff.
I don't know, yeah.
We'll ask Lamar.
We'll have to ask K-Town and Lamar, since he's the lead on the Bluetooth stuff.
Oh, quick explanation of multiplexing. Just general overview.
Well, as far as I know, it's a way to get more of something. That's as far as I know. Yeah.
That's how a lot of multiple buttons.
I'm guessing that's how all the things
with
done.
limited GPIO. It's what people will use.
Yeah.
You can also Google it for a much better explanation.
I'm gonna have to Google it. Yeah. All right. Cool.
All right. Moving on to this week's work in progress.
Prototyping. Is it this guy?
I think that's the first thing on the list. Yeah. So everybody was clamoring for
everybody was kung fu fighting.
Yeah. Everybody was asking for a servo version of.
Do you guys remember? Was it last week's project?
Yeah.
Yay! So huge shout out to Steve UT on Thingiverse. Steve put together this design originally, and a couple of folks, including myself, wanted this version where you can have an LED in the eye and a servo in the body. So I designed this little backing here to house a SG92R microservo and a little slide switch. And inside is a Trinket microcontroller. A huge shout out to Phil B, who helped me write some randomness code for making the servo go and making the lights light up at random intervals. So it gives it a little bit of sense that it's alive. It's kind of searching out. So this is a guardian. This is a character from the video game Zelda Breath of the Wild. These are bad guys. These are little robots that used to be good, but Calamity Gammon messed everything up. So this isn't finished yet. We actually, Steve is working on a version where it's going to be dual extruded, so all this like detail here, all this little curvy stuff is supposed to be a different color. It's kind of blue. Same thing with the face here. So this is really cool. If you check out my Instagram, you can see what it looks like without the skin. That's the more interesting part to me, because kind of figuring out how to mount the servo and wire the LED so that it doesn't choke itself, so it doesn't get caught up in the horn. So that was a little bit of a challenge, yeah. I haven't really done any work with a servo or animatronics, so like maybe this is kind of like a entryway into it, which is kind of cool. I still have to print out the arms and stuff like that. I'm probably going to opt out instead of putting LEDs in each little arm like we did in the first version. it's not really true to the kind of aesthetic of the game. There aren't LEDs on his claws. It's really on his eye. So I don't know. I hope you guys like it. We'll be releasing this project in the coming weeks or so, since we have some things in the pipeline. But this is a lot of fun. A lot of fun making this thing. And again, huge shout out to Steve for the design, and huge shout out to Phil B for the software.
Yeah, so it's the randomization of this that makes it really come to life. I really like the way that it blinks, scans around.
Mm-hmm. Yeah, and this is using the tiny servo library for Arduino. So this is all done with Arduino and C. Very cool. Yeah, just a trinket. That's it, and a battery.
Did you remember to ask him if the way he does the dual extrusion to cut through? Because I think it would be cool to do the translucent material as a dual extrusion, then have like another LED inside that shines.
I could definitely do that. Another LED, or rather, the LED from the trinket might be enough to light it up. Yeah.
So typical, nice little desk.
Yeah, I think if anybody has a character that needs to move its head, or wants to light up an eye, this would be a great way to start with.
Yes, definitely. Jay Com is saying that he wants this randomization code for his laser servo. It
really does add life to it.
Yes.
When I first wrote it as a prototype, I needed to have something to show Phil B, this is the end result, but it'd be nice if I had some sort of randomness. And I didn't know how complicated it would be. He wrote it in 5 minutes. He was like, here, let me know what you think. And this is whoa, this thing's self-aware now. Yeah. But yeah, I originally programmed it so it would just run through. It would just go like this, blink, this, blink, this. It's such a repeatable pattern that it's so dead and fake. This really makes it look like alive. So can't wait to release the code for you guys on that one. Very, very fun. Yeah. It can be applicable to all sorts of different cosplay things, Halloween decor, animatronics, movie stuff, movie props, a lot of different things.
Yeah. So this is actually not a NeoPixel inside here. It's just a regular LED.
Regular LED. It's wired into pin 1. Okay, yeah.
In the game, does the color of the LED actually change to red?
Yeah, it goes red and then it goes to blue. When he shoots the laser, it's a blue laser that you get shot with.
Okay.
So yeah, it goes from red to blue.
Yeah, definitely. It significantly drives the cost down. It's just a one LED inside.
Yeah, $7 trinket and you get a pack of 5 or something for a couple bucks. The LED.
Simon's saying that you should add another motor in there to move all the legs.
Yeah, I think we're a little bit tight on space.
Yeah, the space is
although it does look like there's room. Not really.
Everything's pretty big.
Do you want to take it out? Turn it off? Let's do it. We'll do it just for you guys.
Oh, here you go.
Yeah, we'll see if I can do it. I think I might need a tool, but the point here, another thing about design is, can I open it? Can I get in there? Kind of. My finger can't get in there to pop it out, but the way Steve designed is actually quite clever, is that it has these little nubs on the side that has a little channel that kind of grooves out.
Charlie's saying, Guardian Laser Cat Toy.
That would be awesome, yeah.
That's a good idea. Do this as.
Yeah, so the lasers are about this thick, or about this long.
Pretty big, yeah.
So from here to here, so it wouldn't really fit in the head. I'd have to make the head bigger.
Everything would need to be scaled, and that's going to throw all the tolerances off.
Perhaps. So I need a better mechanism, or just to open this up a little bit more so I can get in there and take it out.
Threads might not work because you're going to start twisting all the cable.
So you can see there's these little kind of cutouts here, this little groove path, and that's where these nubs here on the side, they kind of lock into place. But this is actually where the servo gets mounted. The servo isn't attached, it just kind of rests on top of this little platform.
So it doesn't continue to turn itself around.
Right, because without this here, nothing moves because the servo's moving itself, because the head just kind of chills out there. So what I have to do now is kind of take out the battery and take out this guy. So we're using a JST slide switch adapter, and that just lets you cut power from it. So it's just two JST connectors, a male and a female. And the head just kind of pops out like this. So there's the head. There's these 2 little slots in the side here, and what keeps the head from popping out is these 2 little things here. So you kind of have to line it up and then unlock it here like that. So that's how it kind of works. So let me show you another visual. It goes in here like that. Find the spot, locks in, and he's free to move. And even without the servo, it's kind of fun to just kind of do that. But yeah. The servo horn, most servos will come with an assortment of servo horns. You can kind of see how the LED wire is coming out there. Let me unravel it so you can see the LED wires here. So that's how that's happened. The head is completely hollow. Getting the LED in there, you kind of had to bend the legs and then kind of just pop it in there. No glue, it just friction fits in there nicely. Pretty cool. And that's pretty much it. Here's the trinket. It's just kind of the older trinket with a mini USB, but the newer ones have micro USB. That's really it. I think I have a resistor on the back of the LED there, just wired to one of the legs. And that's it. You just have 2 connections there and 3 connections for the servo. Very cool. And again, the battery plugs into. You can solder a JST connector right on the bottom of the trinket, which is pretty clever. Bless you. Salut. So I've completely dismantled this robot.
Simon is saying that this makes him want to try to look for a project that would apply.
Yeah, I hope it inspires you. It certainly inspired me.
Yeah.
I had no idea I was going to do this. I just saw it and I was like, let me try it. Let me try it. Let me try it. It's very important you just keep feeding your drive. The more you feed your drive, the more you end up with something concrete.
Yeah.
And yeah. Thank you.
Super cool.
Super cool. You don't have to worry about putting that together. So that's awesome. That is what we're prototyping. Big shout outs to, again, Phil B. and Steve, who designed kind of the outer thing. Yeah. It's really cool when your project, when you can kind of use something that's already out there and just build on top of it. That's what open source is all about and things. So I think that's really cool. It's worth noting. All right, another cool thing that well, actually, I think that's it for what you're prototyping.
Okay. We're going to move on.
All right, we're going to
take a little bit of time, yeah.
Yeah, we're going to skip layer by layer because kind of talked a little bit about it, but let's go right into shop talk. I really want to see a drone fly across the room.
So for this week's Time Lapse Tuesday, we have these really cool prop cards that we printed out by Thingiverse user, there it is.
Hashimi. Hashashi. Check it out. This one. Yeah, check it out. So Pedro, you just got the Spark, the DJI Spark. This is a lot of fun.
Yeah, so we do, electronics, drones, they all go hand in hand. We've done a couple of projects over the years with drones. The new Spark came out, and you told me to immediately grab it before the announcement was even over.
Get it.
So the cool thing about this is some of the prop cards that you're able to get for these, they're not even available officially from DJI until the end of July, I believe. So, can't pronounce his name again.
It's okay.
Decided to 3D print or model and 3D print his own. This is the result. So I did get the Fly More pack, which actually came with these, and I've seemed to have lost where the original ones were.
Not my segment.
Where the hell go?
Well, in any case, going like this.
I know. So in any case, I did come up with 2 different designs on these. A third one now, if you check out the Thingiverse page that he's recently uploaded. So the cool thing about these is because it has such a short battery life for such a tiny, small drone, it's about 16 minutes. Every weight or gram that you're able to shave off of this is really good. So the reason why we would use props would be for indoor flying. A lot of people do the cliche thing that I always see, like, in a big building or like a huge church where they're just flying a drone through there, which would make liability a little bit more easier to swallow if you have some sort of protection around the drone when there's people around. So if you take a look at the Time Lapse Tuesday, the 3D printed ones are actually significantly lighter than the original ones that come with the drone. They're about 10 grams lighter, even with the way that they actually designed them too.
Yeah,
they have, like, it's completely shelled out, and it still weighs more than a 3D printed one. So these are just regular PLA, which would be a little bit more lighter if we, if the garage wasn't so hot. We printed these in ABS, and they'd be a lot more stronger and a lot more lighter. But PLA is what we can easily print here. And just seeing the weight difference, I was okay with just keeping the PLA ones. So the way that they snap on, wish we had the other ones.
They are.
We just had them here for rehearsal too.
I know, I don't understand.
Whatever. So they snap on. They have a nice little mechanism that snaps on. which is probably what's contributing to the weight on these.
Yeah, they have like a metal pen,
Yeah.
which kind of keeps the hinge together. Really nice mechanism, but you kind of don't really need it, do you?
Actually, they're right here. I found them.
Oh. Hey,
Since we need this for demoing how, you know, the weight of these.
Yeah, you really want to demo these. Like, okay, there's a reason why they're 3D printed. Although we have them, here's why 3D printing it is a little bit better.
Yeah, so they have these latch, which makes it a little bit easier to put them on. But even with the way that these are completely shelled out, they're 10 grams more than what the 3D printed ones are. So this is 0% infill that we're using on these. And just by demoing on the scale here, which if you saw the time-lapse Tuesday, you've already seen this.
No, it's for real though.
Yeah, about 39, 38 grams. And then when we stick the 3D printed ones on there, you can right away see that they're like 28 grams. 28, significantly.
Yeah, there's 4 there.
Yeah, so you're shaving off
10 grams.
10 grams is going to give you
that's like
all that
a minute
battery
worth
back.
of flight time. Maybe.
I haven't calculated what
Yeah, we haven't
it is.
calculated, but it's definitely giving you something back.
And
because the heavier you are, the kind of less flight time you have.
Yeah, and if you're a new pilot, you know, you're going to be feeling more comfortable with having these props on. But if, say, you crash into a tree, this latch is going to sort of prevent you from being able to cut loose on these because of the way they just snap right in. And if they do break, you should be able to get these off a lot more easier for flying off of a branch. So these are press fit. They have these little nubs on the side that hold on to the arms. Right here. So I did have to adjust the horizontal compensation on the Delta Go for these to fit with not too much, where it's not too tight on them. So the little nubs hold onto there. And I haven't tried the new design that he just uploaded. I want to try those out. You snap on like that. And it still is a nice small little drone. One of the cool things that a lot of people have asked for is a little servo arm, because a lot of educators like doing the egg drop experiment with motion circuit board. So it'd be really nice for that. And yeah, let's go ahead and demo how this actually flies with these. The grab on these are nice and stable, so they don't flop around. And yeah, let's check this out.
I'm gonna back up, guys. You might want to mute your mic to get really loud.
And one of the things I like about this is because we don't have to hook up a controller to it, we don't have to connect to Wi-Fi or anything. You can just have it face detect your surroundings.
Oh goodness, this could go horribly wrong. Guys, wish us luck.
I mean, it worked during rehearsal, so it should be fine.
Oh god.
And of course, the hand gestures makes it a lot more easier too, not having to use the controller. So I really like the way how, you know, it makes it comfortable to fly indoors. Can you hear me? Oh, you can't hear me. I have the power. Woo! As everything in the studio flies around. So
nothing broke.
So I really like the way that the workflow of, you know, being able to go out into the field or just inside the house without having to take out the remote and you know, connect everything. It definitely takes a lot more time to set up, you know, the calibration. Like some of the older drones, the Phantom 4, you always have to do that little dance for calibrating the IMUs. So this is definitely shaves off a lot of amount of time for setup prep, you know, being able to shoot things. And this is where I really like the 3D printed drones for this, because of the ability to have it lighter weight. So we did try printing these out in CPE, and they're definitely a lot more stronger, but they weigh just 1 gram less than the ABS factory stock drones.
Yeah, I think those are ABS.
Props, yeah.
Probably.
So that's why I just stayed with that PLA, since I was saying earlier, if you do crash, it would be nice to be able to get loose from.
Yeah, that would be nice, because then it wouldn't get caught on a branch.
And you can always print more of these out.
Mm-hmm. Cool.
So there, we did do some tests to see if we can get battery out of this. So if you go back over to the overhead. Oops. one of the older projects that we did with the Mavic and the Phantom 4 was just adding like little ring lights with this. So it's just a little trinket controller on there. And you do have a micro USB port on here. So if we just use a micro USB to micro USB, you are able to get siphon power off of the battery for use with, like we were saying, like a little servo or just NeoPixel lights if you wanted to have a little lighting rig on there.
Quick comment from True Tech: flying paintbrush for metal roofing. Oh, just wave your hand at ground level.
Yeah, that's a good idea.
New way to paint with the drone. Yeah.
So we tested this last night while we were doing the rehearsal for this, and yeah, super surprised that you're able to siphon power from that.
Did it work?
I think I might have.
Is it the orientation?
No, I think I just loosened the cable.
Oh, okay. All right, so this is a USB micro to a USB micro cable.
Micro to micro, yeah.
Never seen one of those.
I know.
Where'd you get this?
I think these actually came with my Google Glass.
Okay, well, you can get them. Wait, oh, this is a different cable.
Yeah.
Okay.
So we'll talk about that, yeah. If you're still on the other, yeah, you can see that the trinket boots up, and you have enough power for powering at least the 24.
It's waiting to receive code, like the bootloader is working, like the DJI knows something.
Yeah, so you can recharge this right off of a mobile power bank, which is cool as well for traveling. Yeah. And just get yourself one of those beefy power bank sets.
So what an easy way to kind of get your microcontroller powered and some NeoPixels. Just plug it into the micro USB port.
So you can do this with the Phantom 4 and the Mavic as well.
Yeah, this is completely really self-contained kind of unit. You could strap it onto your Spark or Mavic, and
so we're just gonna come up
get
with
some NeoPixel UFO.
Yeah, a little grabber right here would be pretty cool. Yeah. The other thing in terms of cables I wanted to talk about was these $2.50 OTG on-the-go micro USB cables that we have in the shop. So a lot of people have been complaining the new way that you connect your controller to your phone is actually by connecting to the Wi-Fi hotspot that the remote control connector makes, which is a different way than you do with the Phantoms or the Mavic. Not always the best, especially if you're like in the suburbs where there's like a ton of Wi-Fi connections. It's super choppy. Like we would go up a little bit. What is it? All the messages.
Yeah. Pikachu did not like. Sorry, Pikachu. We'll try better. Keep going, Pedro. Sorry.
So yeah, the instead of connecting the Wi-Fi connection, we have these on-the-go micro USB host cables that are able to do the down link of the video to this, because otherwise, when there's just too many Wi-Fi connections,
it was
unplayable.
It was unplayable.
So definitely, if you want to pick up one of these Sparks, this is definitely the way to go. Just grab one of these cables to do your video downlink from that.
Ooh.
So it's just a on-the-go host micro and just a regular lightning cable, which is gonna make flying a lot more better.
Yeah. So you can pick up one of those cables if you want over here.
And this should work on even the smallest 3D printer, like a Micro or the Delta Go. It's again, another thing that I like about how portable these are.
And if you want the lightning cable, it's on Amazon.
Yeah,
for like $5. So you can get one of these.
I just need like a 8-inch short little cable for that.
Cool. So when you combine these two cables, you get a nice little flying solution.
A lot more enjoyable flying experience.
Cool.
So that is this week's Time-Lapse Tuesday. You guys can get the files linked, the Thingiverse file.
Yep. Good. Huge shout out to this person here. Yeah. All right. We got some contests. Probably going to go through the contests now. So there's a lot of opportunities, you guys, to win some 3D printers and some stuff here. So this is a mechanical design challenge that we have for Pinshape. It's got 2 days. We've been talking about it for the past weeks now. Check it out if you are interested in submitting one of your mechanical designs to win a Formlabs, or a second place gets a Prusa i3 MK2S kit, or we also have some Adafruit bucks, $100 Adafruit gift card for the first prize. So check this out. I'll have the links down below. Great judges as well. We have a fidget spinner design challenge hosted by Instructables, sponsored by Ultimaker. So here's your chance to win an Ultimaker 2 Go 3D printer. We only have 24 entries, really? guys, I know you don't like fidget spinners, but here's your opportunity to like win a pretty decent, really good 3D
Pretty
printer.
nice Ultimaker there.
Yeah, check it out. There's lots of design contests as well, so be sure to check all those out at Instructables, our friends over there, Instructables. There's also the Bose Build Design Challenge. If fidget spinner is not your thing, but you want to design something for a speaker, this is a really cool one because they give you the design STL files and then you wrap around. So here's the component, make an enclosure for it. You know me, I love me some boxes. There's already 168 entries here. A lot of cool stuff. Oh wow, that's a really cool one. Make a joystick out of your speaker. That's super dope. Very, very cool. You have my permission to use Boomy to win your thing. Go ahead. All right, we got another contest. This one is a collaboration with TinkerCAD and My Mini Factory to win a BQ Witbox 3D printer. There are different types of themes, so a little bit different here. You got the fidget spinners, you got the fingerboards, you got furniture, and you got pots and planners. Some pretty dope prizes here. Check it out. We have some new stuff from Maker Media, makershare.com. This is kind of like a profile place to kind of share your projects. So pretty neat. This is a project by Intel and Make. Becky Stern is on there. Check her out. She has a live stream happening sometime this or next week on Instructables Facebook group. She'll be building a infinity mirror.
Yeah.
So this is really cool. So this is what her space looks like. Throwing a project there. I'm probably going to throw my hats in there and start up a Noe Pedro one. And we also have one from Kirby. This is what a project looks like. Really nice and clean layout. I've seen some of the other sites where you're sharing your projects and there's ads and stuff like that. You know, a little bit cluttery. This one's really nice and clean. Let's hope this stays here and it's here to stay. I kind of like this kind of call out here, the oh moment, like what happened, what was wrong, that was worth kind of talking about. So this is pretty neat. I haven't seen anybody do that yet. So
that's one of the biggest things that a lot of us neglect to mention. Everybody thinks that we just run through it and, you know, first try on everything, but
no, it's first try.
It's probably the 20th try.
Well, we never make mistakes. I mean, just look at the show. Cool. Let's jump right in. So those are all the contests. Check them out.
Yeah. So this week's Community Makes, we start off with a glowing apple.
Yeah, this is from Stuart Riggs. He was here earlier in the morning. So he put together this project. It's kind of a...
Oops. It's like, where's the drone?
Okay. I was going to say, like, dude, this thing's going to explode. No. First try. So this is a really cool, it's called the Apple of Eden base. It's a remix. He took his previous design and just refined it so that it has a little bit more easy to get in there and kind of, it has the snap fit. He shouted me out in the Lair by Lair where he learned how to do the snap fit stuff. So really, really cool. I think it's using an IR sensor so that when you place the ball on the base, it lights up. So you can check it out here.
That's pretty cool.
Really, really neat way to kind of get interactivity to your NeoPixels, right? Just a neat way to do that. So huge shout out to Stuart Riggs. Very, very cool project. Check it out on Thingiverse. This is a project that's also a tutorial/guide. So the awesome folks at Pinshape put together an introduction to Arduino programming. So this is they're calling it the Vex Eye. It must be from a video game or something like that. So it's using an Adafruit Gemma and a Flora NeoPixel, a battery. They just did a nice write-up on putting this project together. Using the Formlabs to make some incredible parts, make some beautiful stuff, man. Like, this is high quality. So it just walks you through. You even have a circuit diagram. Really, really cool stuff. Huge shout out to the folks at Pinshape. They're doing a great job. So check them out. You can download all the files and everything to get your cosplay items like nice and glowy. Very cool. So check that out. It's also here. It was a remix of this design because it was a coin cell. You could also, if you want to just have a really, really simple on and off thing, you can use this kind of base here. Next thing is, this is awesome. Remember the Adafruit Joy Bonnet? This is awesome. From Tronic GR on Thingiverse put together this beautiful Joy Bonnet kind of cabinet, maybe bar top cabinet. I really like how it has like this docking type feature where you can unplug it from the dock. I'm trying to pull up the picture. He's been posting all of his kind of progress, which is a really great thing to do, is to document his. There you go. That's the picture I was looking for. The way it docks into this kind of screen and everything is mounted in the screen. You can see that there's like an amplifier and two speakers. This has got everything. A huge battery. It's crazy. All with a Raspberry Pi Zero. So you get this self-contained portable unit. Very cool. Yeah, this is the way to do it. Here's a little video of him playing it. Let's see if I can read it real quick. So very, very cool. Yeah, runs all the things. Check that out. Check out this project. I'm inspired to make one of these, actually. Pretty cool. So shout out to Thanos on Instagram, on Thingiverse. Great job. FLOWALISTIK, Augustin, did a kind of remix to his letterboard, his DIY letterboard that's 3D printed. He made them into knuckles. He turned them into wearables. Very, very cool. So if you want to have some cool letterboards that are wearable, knuckles, makers are going to make. Let's check it out.
Super cool. I like this one.
This one's really cool too. This is a kind of a wearable fin gripper. So using NinjaFlex to make these like grippy things. Just check out this video. Super dope.
So we've seen these grippers made a couple of different times. I think Alex Hatch made one, as well as
Aiden
has made one too.
Made one, yeah.
They've only made the tip, so this is really cool in terms of not needing a servo, just using
mechanical design,
yeah.
Very, very cool. So check that out. The
really cool
Doc-Ock. Is it Doc-Ock? One of those. Very, very cool. So shout out to you, sir. Black Ram Industries. So all the files are up there. And a nice breakdown of some of the hardware you need to put it together. Very cool. This is awesome. This is an instructable from Circuits.io. Or is this Circuits.io? Something like that. It used to be 123D Circuits from Autodesk. They're now in TinkerCAD. So this is cool. This is a really quick way to kind of make like a BristleBot type platform. So it's a 3D printed little holder for a coin cell and a little motor and a switch. So this walks you through how to build that, and this is part of a bigger thing. This is a part of this here. So TinkerCAD Circuits is now live. Check it out. It's a way to simulate Arduino stuff and simulate circuits and stuff without actually having the hardware. So what they're kind of doing is making it so you can import these components, these circuits, into your TinkerCAD design, and then you just kind of use that to design a skin for the platform. So in this case, it's an LED and a motor. Let's make a little bear that dances around and lights up.
So we wanted some sort of functionality like this, like the parts library forever now. So I'm really happy to see that they finally have implemented this into TinkerCAD itself, since it is web-based. You're able to embed this inside of other websites. So
correct. So that's great.
Shout outs to that.
Super cool. So check it out if you want to. I think this is a better. This is way better than fritzing because it's simulated and actually shows you, and you can actually code and stuff. It's really, really awesome. Shout outs to the TinkerCAD folks for doing awesome work. This is another project from the community. This is from JSCHW on Thingiverse. It is a Raspberry Pi and a media hat. So you can make a advanced music player. I think this is cool. This would be really nice to see like a fat DAC in there. Maybe do some Airplaying. I know a really good tutorial on getting Airplay on your Pi Zero from Mr. Kirby himself. Stuff with Kirby. So check him out too. Just kind of bringing this back out there. I've been meaning to do this project. I still haven't done it. So it's more of a to do for me. Hey, Noe, you need to freaking do this because Kirby did it and it's great. So I want to do that. Great job, Kirby and JSCHW. That's it. That was Kirby's. That's it. That's all the community makes. If you guys want to share your project with us, we'd love to share them. You can do so by hitting us up in the social chats, Twitters or Instagrams or wherever.
Yeah, a lot of the requests actually come in through support@adafruit.com, so you can email Jessica and team in there and get those over to us.
Yeah. Well, that's going to be it for the show. We're going to be on later tonight for show and tell, and then Ask an Engineer. So you can check that out tonight. If you want to share your project with Lamar and Phil and myself and all the lovely people that come on there, you can do so. Just go to the YouTube. We'll send the invite link in the chat room, so just keep your eye in the chat. Again, that is tonight at 7:30 Eastern Time. Yeah, got some great lineup of shows. Tinker Pixie, Aaron St. Blaine, just doing it up with the Hot Flash. We got Watch 20Ds every Friday. John Park's working on his new thing. I think it's going to be out later this week.
I saw something new uploaded, yes.
Indeed, it was on like yesterday. Yeah, So we're doing it back up again.
Solder paste extruder. Looks really cool.
Yeah, awesome
Check that
stuff.
out.
Well, if you want to support your maker habits, oh my goodness, and support your maker habits and support Adafruit as a whole, you can do so by picking something up in the shop every once in a while. That's all we ask.
Yep.
That's all we ask.
Do we want to do this week's Q&A?
Oh, yeah. All right. What about Q&A, writer? Well, yeah, we'll do it. It's so much better doing this at 11 a.m.
I know. Skinny Mouse is asking, the shell for this is done with a 3D printer? I think they're talking about...
Shell? Which shell?
I think they're talking about the little arcade Pi Bonnet.
Yeah.
You did that in SketchUp, so yeah. It is 3D printed. How do you program a LED in C language?
There's a lot of great Blink tutorials on Arduino's site, and also learn.adafruit.com. Oh.
Search for that.
You just pull it high and pull it low, put a delay in between.
And Skinny Mouse is also receiving his Haku FX88.
Oh, that's awesome. Congrats on your lovely purchase. It's like getting like a super sports car, but for like soldering.
Kirby is asking if the Mavic controller works with the Spark.
I don't think so.
No, it does not. The Mavic uses... it's not Lightbridge. It's something better than Lightbridge.
It's a different protocol for like communicating? Interesting.
The Mavic uses just regular radio, I think. So it's not compatible.
Is the remote come with it?
The remote does not come with it.
You've got a pack,
if you get
right?
if you get the combo pack, it will come with it.
Okay.
And he's saying that the price of the Spark after controller isn't much less than the Mavic. He's saying Costco carries the Mavic in the store. Yeah, I noticed that there are a lot more available now. They were at the Apple store when we went in the other day. The Mavic, when I was looking at, sort of evaluating the workflow that I've now developed with it, it's a lot more faster than having to, take the Mavic out, unfold the arms, put it down on the floor. Because although you could launch from your hand or land on your hand, the Spark has the face detection, so it's able to see that you are holding it and lift off from your hand and land on your hand a lot more easier than the Mavic can. Okay. So it's one of those, balancing acts of, do you want ultra portability? It doesn't have 4K image, it doesn't have a 3-axis gimbal like the Mavic does.
Yep.
But for like vacationing, I'll definitely take the Spark, even though it has like half the battery life of the Mavic.
Cool. Next question is from Ryder, who's asking about this new 3D printer, the Obsidian.
$99
3D printer?
Yeah, it looks like
I haven't watched Joel's video yet, so I'm going to do that because I'm kind of interested in about it. Like, is it a real thing and is it worth it? So I don't know. Yeah. Ryder, definitely watch Joel, the 3D Printing Nerd's video on it. I'm going to check that out. Yeah, it's he launched it, what, 2 days ago? Yeah, 2 days ago. Yeah. So I think he has it. He's like, it's real. I think it's real, unless it's photoshopped.
Unless it's like limited quantity.
Yeah, I don't know. So yeah, no thoughts on it. Just interesting, and let's see what happens.
How much is the Mavic? I think it's $7.99. Yeah, maybe you can get a student discount. A lot of people don't know, like if you go to Apple, or I think it's education.apple.com, you can actually get discounts for education. I don't think they actually check your ID still. So you could do that.
You didn't hear that from us?
Actually, no, I heard somebody, if you have access to like the corporate account, you are able to get the corporate business discounts. Somebody got the Spark for like $400.
Oh my god!
After
that's awesome.
The business discount.
Cool. All right.
I think
this is going to be it, guys. Well, thank you so much for joining us on this very strange week where we had ISP problems in the morning and things like that. So we appreciate you bearing with us. It is a live show. Things like this happen all the time. But we'll be here.
Next week.
Keep trying. We'll be here next week, guys. Again, don't forget the coupon code this week is CircuitPy. We'll see you guys later tonight on Ask Engineer. Well, really show and tell.
Show and tell.
But we'll be in the chat room or something.
Yeah.
Just a quick note, this is streamed every Wednesday at normally 11 a.m., but today it was a little bit special. So that's it. All right, guys, this is going to be it. Check out the project. this week. Yeah.
If I can remember which one it is. There you go.
There you go. All right, guys.
See you next week.
Bye, everybody.